What you're looking at here is, does this look like an exponential or a logarithmic graph? Exponential, right? And remember the other day I taught you how to graph them? If we said that we had this function, draw the graph. Well, actually, I am not really that interested in you spending a lot of time graphing functions. I'm actually more interested in you seeing the graph and then writing the function. Do you see how there's two directions there? You could be given the function and draw the graph, or you can be given the graph and write the function. And I think it's more useful for you to be given the graph and write the function. Okay? It's also a lot easier on me because it takes a long time to draw graphs. But I can give you like a whole mess of graphs and you can figure them out. So here's what I want to show you. This is the graph of y equals 2 to the x power. You actually graphed this the other day. And I'll show you how I know that. Because what is the first, I don't know if you remember this. Remember the first step in graphing 2 to the x is you plot the point 0, 1, right? And so look, if this is the coordinate plane, here's the point 0, 1. And this graph here, doesn't it go through the point 0, 1? And then wouldn't we graph flatter to the left? And look at that, isn't this flatter to the left? And then wouldn't we plot the point, oh, and I forgot we'd have to draw the horizontal asymptote, right? And didn't I do that here? You see it? Do you see the dashed line here? Okay. And then we would plot the point 1 comma base, right? 1 comma base. And in this case, what is the base? 2. So we would plot the point 1 comma 2, right? So 1, 2. And doesn't this graph pass through the point 1, 2? And so that's one of the reasons we know that the base of this is 2. And then the last step is to go steeper to the right, correct? And so this has all the qualities of y equals 2 to the x power. Okay? So now what I'm going to show you is, I'm going to show you 4 different kinds of transformations. And those 4 different kinds of transformations of an exponential function are a vertical shift, a horizontal shift, a horizontal reflection, and a vertical reflection. So horizontal reflection, horizontal reflect, vertical reflect, a horizontal shift, that's a sideways shift, and a vertical shift, that's an up and down shift. These are the 4 kinds. And now, here's what I need to show you, is the way that you know what each of these do is, what is horizontal associated with, x or y? X, right? Okay, so reflections deal with negative symbols. So when you put a negative symbol on something, that usually causes a reflection. So basically, to get a horizontal reflection or a vertical reflection, all you're going to do is put a negative on something. But for a horizontal shift or a vertical shift, you have to actually, you have to change the numbers. Okay? And what did we just say horizontal is associated with? X. So you'll see a horizontal shift if you have a number with the x, and you'll see a vertical shift if you have a number. I'm going to say a number with the y, but it's actually, we represent it differently. But I'll show you. Let's just jump right into, let's go to the next graph. Tell me what happens to this graph on this next slide. What did it do? Yeah, it reflects horizontally or vertically? Yeah, no, look, yeah, it's a horizontal, right? Because it flipped sideways, right? So, in order for this to happen, in order to have a horizontal reflection, this is now simply the graph of 2 to the negative x power. The reason I say it's a horizontal reflection is because it flipped sideways. Okay, Terica? In front of the x, yep. In front of the x. Or just in at the beginning of the exponent is a better way to think of it. All right, so we got that. Now, look at the next one. What about that? If this was, yeah, it's a vertical. The original looked like this, correct? And now what happened? It flipped vertically, right? All right, when that happens, when you get a vertical reflection, you put the negative on the base, like that. Do you see? So this is the graph. What we're looking at here right now, that's the graph of y equals negative 2 to the x power. So if you put a negative on the base, it'll flip vertically. And then the third possibility, well, really it's the fourth possibility, because the first possibility is the parent function, is the normal function. Then you have a horizontal shift, or flip, horizontal reflection. Then you have the vertical reflection. Any guesses on the last possibility? Last possibility is both a vertical and horizontal flip.
So vertical is only base, horizontal is
Only exponent. And then if you have a flip of both, see this? This is what, watch this. This is what I call backwards. I call this one backwards. I call this one upside down. I call this one upside down and backwards. So look, when it's upside down and backwards, what am I going to put on here? Negative here and negative here. So this would be negative 2 to the negative x power. So I can have 2 to the x, I can have 2 to the negative x, I can have negative 2 to the x, or I can have negative 2 to the negative x. I can have 2 to the x, I can have negative 2 to the x, I can have 2 to the negative x, and I can have negative 2 to the negative x. What would happen is this: if you have negative 2 to the x, instead of plotting the point 0, 1, you would actually plot the point 0, negative 1. And instead of the first point being 1, or the next point being 1 comma base, it would actually be 1 comma negative base. And you know, and what that would result in is this. Look, they would all be upside down. They would all be below the x-axis. Does that make sense? All right. So now, how are we with the reflections? Are we okay? It's either backwards, or it's upside down, or it's upside down and backwards. Or it's not none of those things. If it's none of those things, then don't put any negatives. All right, let's move on. Now, let's go back to the original function. All right, you guys watching? All right, here we go. Now what I want to show you about are, watch what's going to happen to the graph here. A horizontal shift. Do you see that? See what it did? What did it do? It moved over which direction? Yeah, but which way? There's two horizontals, left and right. It moved to the right, correct? Here's the starting. So look, it goes through these points, right? And then it moves over. Now it's not going through those 2 points anymore. Now it's going through this point and this point, correct? And here's what I need you to understand is that these points, how far did they move to the right? 1 over to the right, okay? The way you would account for that in the function is by doing, you would say y equals 2, instead of the power of x, it would be to the power of x minus 1. Where did I put the shift? With the x. Because it's a horizontal shift, right? Do you guys remember when we were doing polynomial functions that whenever you had an x shift, it was the opposite sign? Like if I had y equals x minus 1 times x plus 2 times x minus 5, where are the zeros? Right, what I mean though is the roots. Yes, set them equal to 0. And what would I get here? 1. Positive 1, right? And what would I get here? Negative 2. And what would I get here? Positive 5, right? So the location of the graph is opposite of the analytical expression, right? So what kind of x shift did we just see happen in this graph? A positive x shift, right? It moved over to the right in the positive direction. And so I'm going to put x minus 1. Does that make sense? This is the starting point. Now watch. Which way did it go? It went to the right, which is a positive shift. So we put by 1, so we put x minus 1. And so now what would this be? How far did this one shift from the original? It moved over 2, right? From here to 1, 2, 1, 2. So what would I put? X minus 2, right? And how about this? It's x minus 3, right? Okay. X minus 4, x minus 5, x minus 6. Now let's go back to the original. All right. So this is the original. Now watch what's going to happen. What did it just do? How far did it shift to the left? It shifted 1, right? It went from here to here, here to all the points moved to the left 1. So what do you think the exponent is now going to be? It's going to be x plus 1. There we go. 2 to the x plus 1 power. And so what I'm trying to show you is that horizontal shifts manifest themselves in the exponent with the x. And so now what would this one be? If it went over 1 more to the left, x to the power of x plus 2, x plus 3, x plus 4, x plus 5, right? Back to the original. We okay? All right. Now we're back to y equals 2 to the x power. All right, the last thing I need to show you. So I've shown you a horizontal reflection. I've shown you a vertical reflection. For a horizontal reflection, you put a negative on the exponent, right? For a vertical reflection, you put a negative on the base, right? For a horizontal shift, you modify the x, correct? Now watch. Everybody watching? I want you guys to see it before I do it. Here's the original, right? Tell me what happens to it. Ready? What did it do? Yeah, it went up how far? 1. You know what's easiest to see when it does a vertical shift? What's that? Well, it doesn't actually shrink. It looked like it shrunk because of up here, because you don't see this anymore. But yes, say that again. The asymptote. You can very clearly see the asymptote. And so the asymptote can actually help you with the vertical shift here. It went up 1, right? So watch what I would do. I would put a plus 1 on the end of the function. I'm not going to change the exponential portion at all. I'm just going to put a plus 1 on the end.
So you would put 5, you would put plus 5.
Yep. And in fact, watch. There's plus 2, plus 3, plus... Oh, that's as far as I went. Plus 3. I didn't have a lot of room on here, you know, on the screen. So this would be this one, because the asymptote is at positive 3. So what I'm saying is that wherever the asymptote is, whatever y value, that's what you put on the end of the function.
The line shift is where basically...
Yeah, wherever not where the graph intercepts the y. In fact, the graph will always intercept the y 1 unit above whatever is here. Like if this says plus 3, then this graph is going to go through the point 0, 4. You know what I mean? So wherever the asymptote is, wherever the asymptote crosses the y-axis, that is what you're going to put on the end. So now let's go back to the beginning. All right, now watch. It's going to be a vertical shift again. And let me write this down. Vertical shift. Plus or minus number on the end based on the asymptote. Okay? So now watch what's going to happen. It just went down 1. So now what would it be? Yeah, we put minus 1 on the end. Minus 1. 2 to the x power minus 1. Minus 2. Minus 3. Minus 4. Minus 5. Okay? Now let's talk about logarithms. And by the way, right now I'm just introducing you to the ideas. In a little bit, probably in about 10 minutes, I'm going to show you a procedure for when you look at a graph, how do I figure out what this is? What kind of function is this? Yeah, it has a vertical asymptote, making it what? Making it a logarithm, right? Making it a logarithm. All right, so this is log base 2. Do you know how I know it's log base 2? What's that? Yeah, because, watch this. Because it's going, now you know they all go through the point 1, 0, right? But this one goes through the point 2, 1. So it must be a base of 2. If it went through the point 5, 1, then it would be log base 5. But it's not going through 5, 1. It's going through 2, 1. That makes it log base 2. And it has a vertical asymptote instead of a horizontal asymptote, right? Okay? So, watch this. Everybody ready? Tell me what it does. Which direction? Horizontally. It is backwards, right? It's backwards. So because it's a horizontal flip, where am I going to put the negative? With the x. So log base 2, and instead of just putting an x in here, I'm going to put negative x. Log base 2 of negative x. Do you remember how I said the other day that we can't put 0 or negatives inside of here? Right? Well, now we can put negatives in here, because what is that negative symbol going to do? It's going to turn it into a positive. So if I put negative 9 in here, I'll have negative 9, which will then be positive 9, right? Now I can't plug any positives in. If I plug a positive in, if I put positive 5 in here, it'll then be the logarithm of negative 5, and I can't do that. You can't take a logarithm of a negative number, right? So a backwards reflection of a logarithm will cause you to put a negative on what's on the inside. All right? Okay. Now tell me what you see. What is it now? If this was the original, what is this? It's a vertical reflection, right? It's flipped upside down. See? Look, yeah. These are logarithms. Yep. Yeah, sure. All right. Unfortunately, there's one in the middle. All right. Whoops. Here we go. All right. From here, I'm going to try and double click really fast. Right? It's going up and flat, right? Up and then flat. This one's going down and then flat. Do you see that? So if this is the original, right? Let me draw it in. Okay, there's the original. Now, watch what I'm going to do. How is this related to that one? It's actually not backwards. Backwards would be over here. Correct. Making it a vertical reflection. It was flipped like this. And so where do we put the negative? We put it in front of the log. This is now y equals negative log base 2 of x. It's a reflection. Look, I put it in front of the logarithm. I put the negative in front of the log. So now it's y equals negative log base 2 of x. Last situation. Look at this. This one is now, it's not only upside down, because look, instead of the horizontal instead of it going down along the horizontal, it's going up. And instead of it being on the right side, it's on the left side. This one is upside down and backwards, right? It's upside down and backwards. So where am I going to put the negatives? Upside down and backwards. So this would be negative log base 2 of negative x. Okay? So here's the deal. If a logarithm graph is on the right side of the asymptote, then the inside will not be negative. If a logarithm is on the left side of the asymptote, then it will be negative. See if we go back one more. See how now the logarithm is on the left side of the asymptote? That means that we have to put a negative inside of the argument with the x. This is backwards, this is upside down. So no negative here, it's not upside down. No negative here, it's not backwards. But now, what happens if it is both upside down and backwards? You'd negative on both of them. You put a negative here and a negative here. Okay? Okay. We okay so far? Have we? All right, so that's reflections. Now let's talk about, here's the original again. Here's the original. Erase these negatives. All right? Okay. Watch what's about to happen. You have to see it happen. Tell me what's about to happen. Tell me what happens. What did the graph do? Yeah. Oh, it actually didn't go up. Look, hang on, let's look at it again. Oh, it didn't go down either. See, it looks like it went down because here it looks like it goes down, but look at the asymptote. Look what it did. It actually, all it really did, it just shifted to the right. This is a horizontal shift to the right by 1. So what would I put, a -1 or a +1? -1, and I'd put it with the x inside. So I'd put log base 2 of x minus 1. So this is log base 2 of x minus 1. Right? Now watch. It's going to go to the right one more. Now do you see how easy it is to see a horizontal shift of a logarithm? Why is it so easy to see it? The asymptote helps you to see it, right? Now here's what I need to tell you is on the problems that I'm giving you, I'm not drawing in the asymptote. You have to draw in the asymptote. But it's easy to see where the asymptote is because all you have to do is find the part of the graph that goes vertical, that lines up with a line. All right, and now there's x minus 3, x minus 4, and now we're back to normal. Did you want to see that again? Yes. Okay, here's the original. Here's x minus 1, x minus 2, x minus 3, x minus 4. That's a horizontal shift, yep. Notice how in the exponential function, the asymptote only moved with a vertical shift, right? But now with a logarithm, the asymptote is moving with a horizontal shift. Why is that? Because they are, starts with an I, because they are inverses. Remember how with inverses you swap the x and the y? Everything vertical becomes horizontal. Everything that's x becomes y, and vice versa, right? Okay.
So anything dealing with horizontal, anything dealing with the x,
becomes y.
and then vertical deal with the base.
Let's look at vertical in just a minute. All right, so now look, watch this, guys. We're still dealing in horizontal shifts. Watch. What kind of shift was that? A leftward shift, right? By how far? 1. So what would we write? X plus 1. Yep. X plus 1. Okay. How about this one? Plus 2, plus 3, plus 4, plus 5. There we go. Back to normal. Okay. So do you see the idea? Anytime it's a rightward shift, it's always x minus a number. Anytime it's a leftward shift, it's x plus a number. And it can be an exponential function or a logarithmic function. By the way, this also works on other kinds of functions too. It works on trigonometric functions, which you won't do until next year. It works on polynomial functions. It works on linear functions. It works on quadratic functions. It's easier to see on exponential and logarithmic functions, though. All right, so back to the original. Now, ready? Can anybody predict what I'm about to do? We only have one thing left to learn. Yep, vertical shifts, right? Okay, so watch what's going to happen here. What did it just do? It went up by 1, right? And it's harder to see it going up by 1 because the asymptote didn't change. But watch this. If I plot the point 1, 0 and the point 2, 1, now when I do the vertical shift, it's easier to see. Now it goes through the point 1, 1 and the point 2, 2. You see that? All the points went up by 1. Yep, go ahead. Yep, so we'd have log base 2 of x, and then on the end of it, we would put a plus 1. This is not inside the parentheses. This is outside the parentheses. And then how about this one? What would that be? Plus 2, then plus 3, and back to normal. Okay. Last one, ready? Which way is it going to go? It's going to go down. And you can tell that it just went down if you plot this point and this point right here. See, what you're doing is you're always plotting a point. Do you notice the asymptote? Do you notice that the asymptote always has one point that's 1 unit away from it? That's how you're going to know how to identify it when you're just given something where you have no idea what it is. The first step is always to draw in an asymptote, and the second step is always to plot a single point. So this one would be minus 1. We would put a minus 1 on the end of the logarithm. Yeah, this is a vertical shift, yep. And vertical shifts work the same way as with exponential. We put a plus or a minus on the end of the function. Horizontal shifts get a plus or a minus with the x. Vertical reflections, we put a negative in front of the function, and horizontal reflections, we put a negative with the x. Yeah.
Sorry, if it's not too much, you think you can write the equations for each of them?
Sure. Now, note that, okay, so this one, what we're looking at right now is log base 2 of x minus 1. This is log base 2 of x minus 2. This is log base 2 of x minus 3.
No, I was talking.
Oh,
No, those sides right there, horizontal.
oh, I see what you're saying. Yeah, here, I'll give you an example. Here we go. How about this? Guys, watch this. I'm going to put exponential here, right? And then I'm going to put logarithmic here. I think this is what Joshua was asking for. Horizontal reflection would be y equals 2 to the negative x, right? Vertical reflection would be y equals negative 2 to the x. Horizontal shift would be y equals 2 to the x minus h. And then vertical shift would be y equals 2 to the x plus k. This represents a horizontal reflection, this represents a vertical reflection, this represents a horizontal shift, and this represents a vertical shift. On a logarithm, it would be a horizontal reflection would be y equals log base 2 of negative x. A vertical reflection would be y equals negative log base 2 of x. A horizontal shift would be y equals log base 2 of x minus h. And a vertical shift would be y equals log base 2 of x, and then on the end, plus k. These are basically the rules for all the 4 different things that could happen to these 2 different things. So you can see it's 8 possibilities. And you can combine these. You could have negative log base 2 of negative x minus h plus k if all 4 of these things are happening to it. Okay? And what I'd now like to do, after y'all finish writing this down, is I want to go, in addition, this slideshow isn't done. I have several example problems to help you learn the steps for deciphering an exponential or logarithmic function. Let's say that I am given this problem. I'm given this problem. My first decision is this an exponential graph or is this a logarithmic graph? Because I mixed them all together on your worksheet. Yeah, how do we know that? Yeah, well, there's a couple ways, because it could be a negative logarithmic graph. This could be an upside down and backwards logarithm. Here's what you're looking for. The first thing you're looking for is the asymptote. Where is it steep or flat? Okay, do you notice here it's not going vertical along a line, but here it is going horizontal along a line. So the very first thing that you want to do is draw an asymptote. That's the first thing you want to do. Drawing an asymptote will automatically tell you whether it's a logarithm or an exponential, because the asymptote, if the asymptote is horizontal, it's exponential. If the asymptote is vertical, it's logarithm. So look, we're going to work toward that. I'm trying to give you steps on how to do the whole thing. Do you understand that? We are given a graph, we are identifying the whole function. And the first step in figuring it out for yourself is drawing in an asymptote. So I'm going to draw an asymptote right here. Because it is a horizontal asymptote, what kind of function does that automatically make it? It automatically makes it an exponential. So I know that it's going to be y equals something to the something power, right? It's going to be y equals something to the something power. Okay? Now that I know where the asymptote is on an exponential function, the asymptote will tell me the vertical shift. So step 2 is, actually, you know what? Instead of doing that, let's get to that. The second thing you should do once you draw the asymptote is plot a point on the curve 1 unit up, or excuse me, sorry, 1 unit away. Let's say 1 unit away. 1 unit away from the asymptote. So it wouldn't matter whether it was a vertical asymptote or a horizontal asymptote. What you want to do is go to the asymptote and go 1 unit away from the asymptote. So if this is the asymptote, what is 1 unit away? Up or down? Or left or right? Up, right? If it was a logarithmic function, you would either go left or right. So in this case, I'm going to go 1 unit up because I want to go in the direction of the curve. Along that line, parallel to the asymptote, I want to touch the curve. Where is that? Here, right? So I'm going to put a dot right there. I'm going to plot a point. That point is a very important point. That point is basically your 0, 1 point. The next step, step 3. Go 1 unit over from the point in step 2. The one we just found. Go 1 unit over from the point in step 2 and move. Now, right or left if it's exponential, but it would be up or down if it was logarithmic because it's the inverse. You're going to go 1 unit over from the point in step 2 and plot a point on the graph. All right, so watch. So from here, I want to go the direction where the graph opens. So I'm going to go this direction, 1 unit over. If this had a backward reflection, I would go the other direction. And you'll see that when we do more examples. So now, if I go 1 unit over from this, look at this, 1 unit over, and then go to the curve and plot a point. That point is going to tell me what the base of this function is. The distance between that point and the asymptote is the base. What's that? No. No. Okay, ready? Listen, everybody listen. The distance between that point and the asymptote. 2, right. Not the origin, not the x-axis, not the y-axis. How far is that point from the asymptote? Do you see this distance? How far is that? 2. Therefore, the base of this is 2. So this is 2 to the power of. Is this graph upside down? No. Therefore, we are not going to put a negative in front of the 2. Is this graph backwards? No. Therefore, we are not going to put an x in the x or a negative in the exponent. Go ahead. What's that? I'm sorry. So we would just put an, well, here's the thing is, we're going to put an x, but we're going to put it in parentheses with something else. Because there's a horizontal shift, right? And the way you find the horizontal shift is, remember the first point we plotted right here? Where is that point supposed to be? It's supposed to be at x equals 0, right? It's supposed to be right here. So how far over did it travel? 4, right? Which direction? To the right. So what is it going to be? X minus 4, right? Because it's got a right shift by 4. What about the vertical shift? Here's the x-axis. Did it go up or down? Where's the asymptote? How far down? Down 3, right? So I'm going to put a minus 3, and there's the equation. Yeah, let's see. What did we do next? So 3, go 1 unit over from the point in step 2 and plot a point on the graph. Okay? Step 4, the base. The base of the function is the distance between the asymptote and the point from step 3. Step 5. If upside down, put negative sign on front. 6. If backwards, put negative sign on x. But here's the thing is, you're actually putting it on in the front of the x inside parentheses. You're putting it here. Like if this was backwards, I wouldn't put the negative in here. I'd put it on the outside like that. And then step 7. Step 7. Horizontal shift adjustment. I mean, I don't know any other way to say it other than adjust your x. You know, you're going to have an x plus, or x minus h, and then step 9, vertical shift adjustment, which is on the end. On the end. We probably have enough time to do maybe 2 more. What's that?
You skipped to 8.
Oops, that's an 8. There we go.